All right, we're going over the problems from section 10.3. So I'm just asking the class if they have any questions on 17 through 21, those first three on page 638.
Yeah, number 17. How do you graph it?
Number 17. How do you graph 17 where there's a graph? Well, that's a tough one. Let's take a look at 17. How do you graph it? You just put your paper over it and copy, because it's there.
Well, no, that's not what I meant. I meant my paper.
All right. All right. Let's take a look at 19. All right, number 19, we've got x plus 2 squared over 1. And I'm going to write that as 1 squared plus, this is y minus 1 squared. Now that's over a 4, but I'm going to put that over 2 squared. And that's equal to 1. Now, the very first thing that you've got to do is go through and tell me what A, B, and C are. So, what is A? What's A? What is it? A is what? All right. A is 2 because it's the bigger number, and it just happens to be under the y term right now. Because it's under the y, what does that mean about the ellipse? The major axis is vertical. Okay? Major axis is vertical because the bigger number is underneath the y. Then B is equal to 1, right? So how do you figure out what C is equal to? Well, we have to use the equation C squared is equal to A squared minus B squared. All right? It's always going to be that bigger length minus the smaller one from the numbers that we're given. Well, this is just 4 minus 1. That's 3. That's C squared. So C is equal to root 3. All right? Now, what does this tell us? It tells us the distance from the center to each focus on either side is going to be the square root of 3. Now, the square root of 3, if you punch it in on your calculator, that's going to be approximately 1.7 something on out. Okay? Well, the distance from the center to the vertex on the major axis is 2 units. So we're talking about from 1.7 to 2. There's just a little bit of space between the vertex and the focus there. Well, let's go through and start putting the points down. I'm going to start with the center. We always start with the center. And the center is located at -2, +1. You set the x plus 2 equal to 0. You get a -2. You set the y minus 1 equal to 0. You get y is equal to 1. And now then, the next 2 points that you're going to put down intentionally are the 2 foci. They're going to be above and beneath because we've already said the major axis is vertical. So I'm going to put this focus, I'm going to call it focus 1 here, and I'll leave a little bit of space. But how do we find that first focus, the one on top? Well, the x-coordinate has to be exactly the same. In fact, we can put that in both of these because it's vertical. There's nothing changing as far as x. But now then, for the y-coordinate, how far up are we moving from 1? Root 3. So what do we put for this y-coordinate here for focus 1? 1 plus root 3. Now, if you get that focus, then the other focus is real easy. Because since we went up root 3 here and have 1 plus root 3, focus 2 has got to be 1 minus root 3. We're still going up root 3 and down root 3 from that center point. Right? Well, now that we got the 2 foci down, vertex 1, vertex 2. These are the 2 that I put down first because they're on the major axis. Now, how far are we going from the center? We're going that length A, right? So, again, -2 here, -2 here. All of the x's for all 5 of these points are going to be the same. It's vertical. Now then, from the center at y equals 1, we're going up 2. So this y coordinate here is 1 plus 2, which is 3. Well, say it again. We're going up 2 because this is the length on the semi-major axis, right? That's to the vertex. That's as far away as you can be on the ellipse and still be on the ellipse, right? Up or down. Well, we're going to subtract 2 from 1, and so this will be a -1. So notice we've gone that length A for both of these up and down, and that gives us the vertices that are on the major axis, right? That's as far away as you can be from the center. Well, now then, yeah. Why did we do 2? All right, the reason why we're moving 2 is because this value here, A equals 2, that's the length of the semi-major. That's half of the major axis. The entire major axis length is 4, okay? Well, since we go from the center, we got to go up 2, we got to go down 2 from that center point, okay? And now then, we're going to get vertex 3 and 4 to the left and right. And again, every time that you're putting these points down, don't just list the points and say, oh, here's the 4 vertices. Here's the 2 foci. Okay? Put them visually like this so that when you do have to graph it, well, you're doing the same thing. Well, our distance that we're going left and right now is B. Right? That's on the semi-minor axis. So I've got to go 1 unit to the left of -2. Which is going to put me where? -3, 1. Well, and then if I go 1 unit to the right of the center, -2, 1, it's going to be -1, 1. Right here or here? On the left? Because we're coming to the left, we're now on the minor axis, okay? The minor axis value B is equal to 1. That's half of the minor axis. That's from the center out. And so we've got to subtract 1 from the -2 right here. Oh, that stays the same because we're horizontal. Yep. See, all the y values here, they're all 1 because you're horizontal. It's on the line y equals 1. Just like on this one, all of the x values are -2. That's along the line x equals -2.
Wait, but -1 minus 2 be -3. Do you add 1 to the other side? -1 plus 1 and then it equals -1 on the right side.
Yep. Okay. All right. Now that we have these 7 points, it's going to ask to graph it. Well, let's do that. Let me move this right up here. But I want to graph it on GeoGebra because that's just a little easier for me to put some points down, and plus I don't have any graph paper because freehanding this stuff is really bad. And you want to put it on graph paper too so that you get a pretty good idea of what this thing looks like. Let's start at, what is that, -2, 3? No, let's go to -2, 1. That's our center point. I got to be negative. -2, 1, that's my first point. -2, 1 right there. Well, now I'm going to go through and kind of guess these 2 foci. It's 1 plus the square root of 3. Again, we're saying that's it's almost 1 point, it's a little 1.7 from that. So I'm going to zoom in some right here just so I can see a little better where that should be. 1.7, that's 1/2, 1, 1 1/2. See, 1.7 is going to be about right there. Right, that's pretty close. So I'm just saying that's the square root of 3. Well, I've got to do the same thing on the other side. I've got to come down 1.5. It is. If you look at the number that's there, it is 1.7 plus 1. What I'm saying is the distance from the center that I'm going. See, I'm starting here. I'm not starting, I'm not adding the 1 to it. I'm just saying 1 plus. Here's my root 7. Here's my, root 3, which is approximately 1.7. Those are the two foci. Now then, how do we find the two vertices that are on the major axis? Well, you start here at negative 2, 1, and you're going up how much? So our value here was 2. So I'm going to come up from 1, 2. See, there's the, I said those were pretty close together, the focus and the vertex there. It's the same thing on this side. Now then, how far do we need to go left and right? Let me scoot this over some. Well, B is 1. So I've got to go 1 unit to the left and 1 unit to the right. Again, I've zoomed in so I can see, so these are half every time I go. Here's 1 unit to the left. That's negative 3, 1, right? See, I changed the scale because I zoomed in so much. So that's the scale change. But this is 1 unit to the right. Okay? Now, when you're graphing this, what you have to do is go through and take this point. I would start at D here and try to make an ellipse kind of come out like that, and then come down here and do the exact same thing. I start at the pointier vertices, right? The ones that are a little, they're not pointy, but you know what I mean. And then I do the same thing on this side and do the same thing on this side. You're not going to have true ellipses formed. But now take a look at this tool, because GeoGebra has this ellipse tool where you go and pick your two vertices, your two foci, all right? And now then, I'm going to pop it out until I get, now look at that. That's not too bad. We've got D exactly on it, and E just it's a little bit above, but that's pretty close, because really we're freehanding here on GeoGebra now. We didn't get the exact values for one. We could have, right? It's possible to go through and put, what is that? Negative 2, 1 plus the square root of 3, negative 2, 1 minus the square root of 3. You can do that. I didn't want to take time for it. But you see, that's the ellipse that's formed. Now, one thing that I wanted to ask you that's not on these problems, what's the eccentricity of this ellipse? All right, eccentricity. It's the ratio of the distance to the focus, C, versus the distance to the vertex on a major axis, A. Now, this is, C is root 3, and A was 2. So that's the square root of 3 over 2. Now, we've seen the square root of 3 over 2 from some of our trig values on the unit circle. That's the cosine of 30 degrees. It's sine of 60. But if you actually punch that in on your calculator, that's going to be about 0.85 something, right? Now, 0.85 something, that's fairly 0.86, right? 0.87, all right, it's even more than what I thought it was. We'll take that as 0.87 then. That's fairly eccentric. In fact, when you have an eccentricity that's above 9, the shape of this thing starts getting very, very thin, right? And if you get something above 0.95, it starts looking like it's almost getting flat, all right? Now, see, you can tell that is definitely not a circle. When you get below 0.25 for your eccentricity, it's kind of hard to tell that that's not really a circle, right? Because it just looks so much like it. Okay, the question is, how do you graph the minus square root 3 plus the square root 3? What I do is, again, I'm doing this visually, putting my points down. I always get the two foci first, and normally they're the worst numbers. They don't have to be, but typically they are. And once you find what that is, see, I just went up, whatever that focal length was, root 3. I don't try to go through and put this as a decimal. I leave it in the exact form, 1 plus root 3, 1 minus root 3. Right? And sometimes the values on the vertices will be kind of ugly too, and you'll have to do a plus minus on those as well. But that's it. Once you want to go through and plot it, like we did on GeoGebra, what I was doing there was trying to find, well, what is that square root of 3 approximately that's above? Yeah, I'm just getting. You're not gonna. It's not going to be a perfect sketch, right? It's just going to be, this is real close. And that's the reason why I was showing this right here when I actually went into the tool on GeoGebra and, where it'll make it exact. Ooh, that was pretty good. That's pretty good. Now, what you have to do is fill in these sides right here. All right? That's the hard part, making it look like an ellipse. Some people will go through and I'll have a shape that looks more like a diamond than I have an ellipse because they're using line segments to go from one vertex to the other. That gets points taken off. All right? You've got to try and make it curve somewhat. All right? Is that okay for number, what was that? 19? All right. Other questions from this set? 17? We can do 17. Okay. 17, what they're giving us is the graph. So let's take a look at the graph, and I want you to tell me, because see, I'm still going to put the points down just like I did for the other one where I didn't have the graph. I'm going to put the center down first. And that's at what? -2, 0. All right? Well, what they don't tell you directly are the values for A and B. Now, A is the bigger number. It's the distance from the center to a vertex on the major axis. So my question is, how far is it from that center to a vertex on the major axis? It's 4. So I'm going to write this down. A is equal to 4. That's right. Okay, when we write it down, it'll be something squared. Now then, B is equal to 2 because that's the distance on the minor axis, right, from the center. You're going up, and they've got that point that's labeled there. What is that? -2, 2, right? The 4, this distance right here, if you start at the center, you've got to go to the vertex on the major axis. Well, that's the furthest point that you can be. You just count. You're not going to have any weird ones, right? Not on this stuff. So on that one, you get the graph. They don't tell you directly what A is, but they expect you to pull it off of the graph. And then B, they've got it on the graph. What they don't give you is C. Well, you've got to figure out what C is. So C squared is equal to A squared minus B squared. Well, let's take a look and see what that is. A squared, that's going to be 16 minus. Yep. It's always, for an ellipse, it's always A squared minus B squared, which is the semi-major axis length squared minus the semi-minor length squared. Now, when we get to hyperbolas, it's different, all right? But for ellipses, it's always the A squared minus B squared. Got to keep that separated. So this is equal to 12, which means C is equal to 2 root 3. That's it. Well, let's take a look at this just a second, because I know it doesn't ask about eccentricity, but we're going to talk about eccentricity here. You just do C divided by A. We'll take a look at what we have when we take C divided by A. 2 root 3 divided by 4. What simplifies there?
Hold on.
No, I don't want 0.866. I want root 3 over 2.
Oh.
Wait a second. It seems like I've seen an ellipse with an eccentricity of root 3 over 2. In fact, if we just go back to number 19, which we did first, there's the eccentricity of root 3 over 2. Now, these ellipses are not the same ellipse. These are similar ellipses. Remember similar shapes? So the eccentricity is the same for 19 as it is now for 17. So because the eccentricity is the same, the ratios of the lengths are the same. These are similar.
But how do you write the equation?
Oh, well, how do you write the equation? You want to do that first? All right. Do you want to go through and put the points down like we would need to?
Wait, can't the opposite of
The opposite of the coordinates. Let me... I'm not sure exactly what you're asking there. The question was this. Ask it again. I've got to repeat it for Jake.
Okay. Well, you know how in the first one,
Well, you know how in the first one,
it gave us the equation
it gave us the equation.
that x plus 2 over 1 squared plus y minus 1, and then we just took
The x plus 2 squared over 1 plus y minus 1 squared over 4 equals 1.
Yeah, so then we just set them equal to 0.
Yeah, so then we just set them equal to 0.
And
Now, the part that she's talking about set them equal to 0 is the x
you put it on
the x plus 2 and the y minus 1.
Yeah, so I'm asking if we could just do that with that.
We can get the center right now. In other words, because we know where the center is, that was given as on the graph, we can go through and actually put that part in. All right. I'm going to wait to do that because what I want to do first is get all the points. Because, see, it's asking us for the foci here.
Oh, we do that.
I'm doing the thing. Now, my question is, which direction, is it a horizontal or is it a vertical major axis? How do you know it's horizontal? You've got the graph. All right. So you don't have to figure out by numbers. You can look at it for 17. All right. So I'm going to go through left and right then. Focus 1 here to the left. Focus 2 here to the right. And I want to get these two foci first. Again, this is part of 17. This is not anything extra. How far are you moving to the left and right of that center? To the foci. 2 root 3. Okay? So if you move to the left 2 root 3 from negative 2, 0, what are the coordinates of this going to be? Negative 2 minus 2 root 3, comma, 0. I'm having to put that pretty small because I wrote it too cramped up in there. It's negative 2 minus 2 root 3. You're going to the left. See, the y value is still the same. To the right, then, is negative 2 plus 2 root 3, 0. All we're saying is we're going that 2 root 3 left to right of the center, and it's, yeah, we've got to find the foci. They ask us for that, and now we're going to go the extra mile and put the vertices like we didn't have the graph. Okay? Because see, on this, we could actually just look at it and say, oh, here they are. We can get all 4 points. But see, if we didn't, like most of the other problems will be, we've got to go through and put down all 4 vertices. So I'm going to put the 2 vertices here along the major axis. And how far are we going left and right? We're going 4, right? This again, from the center. So negative 2, 4 to the left of that is what? Negative what? Negative 6. Is that right? So negative 2 minus, that's a negative 6. And see, we don't have to have that minus. We can combine then minus 2 minus 4. And then it's 0. Right? When we go to the vertex 2 over here to the right, we're starting from negative 2, and we're moving 4 units to the right, which leaves us at 2, 0. If you look at that graph, it's the distance from the center. A is the distance from the center to the vertex on the major axis, right? B is always on the minor axis from the center, right? Now then, we've got to find the two vertices above and beneath. And my question is, how do you find the vertex that's above? Yeah, you add 2. Or you can just look on the graph, which it's there, right? Because see, in this case, they give us that one. And so that's negative 2, 2. See, that's 2 above. That's the B length above. But we got to go beneath it as well. Negative 2, negative 2. Now, why don't they ask you to graph this one? Because that's what we started with. All right? That's the difference between these two. But now then, we've got to go through and write this as something in standard form. See, we start from the center. So now then, let's put x, what do we do with the minus 2? It's plus 2 squared over, I'll put something here in a minute, plus y minus 0, which is just y squared, over something here in a minute. What goes on the right-hand side over here? 1. Standard form is always a 1 for an ellipse and a hyperbola. We'll be doing the same thing in the next set. All right, it'll be equal to 1 for a hyperbola as well. And now then, where's our major axis? It's the x. It's the horizontal. So what goes underneath it? Not 4. Why is it 16? It's the squared. All right. So what you'll see for the answer in the back of the textbook, they're not going to leave it as 4 squared. They're going to put 16 right here, and then underneath the y, all right, that's our minor axis now. That's going to be the 2 squared or the 4. And so here is our standard form for this ellipse. X plus 2 squared over 16 plus y squared over 4 is equal to 1. All right? So depending on what you're given, if it's a graph, you still got to go through and find out what A, B, and C are. All right? If they give you an equation, now take a look at problems, what is it, 23 through 29. These they give you not the standard form or a graph, they give you the general form. All right? They give you the general form. You've got to convert it first to standard form. Once you have it as standard form, then you do all this stuff again. Let's do 23. 23 has this. 4x squared plus y squared minus 8x plus 6y plus 9 equals 0. All right. Once you have it written down, as it is in the textbook, we've got to go through and start grouping by our variables.
Do you want to turn this into the format that like was used for like 19?
Yes, we're turning this into standard form, which is like 19 and 21.
Solve for it. Okay.
All right. But we're going to, this is just like what we did in the first section with circles, right? Section 2. We're going to have to complete the square. And so we've got to group the variables together that are alike. So 4x squared minus 8x. Leave a little space after the 8x because you're going to have to put something there when you complete the square. Then put the plus y squared plus 6y. Now, normally, I would tell you, move that plus 9 to the other side as a negative 9. But look at the y squared plus 6y. That y squared plus 6y plus 9 if you leave the 9 there, that's already a perfect square trinomial. Because, see, that is half of 6 squared. That's the 9. So I'm going to leave the 9 this time. This is just a rare occurrence. And then have it equal to 0. Okay? If that were any other number than 9, I'd go ahead and scoot it over. Well, now, what's the very first thing that we have to do for the x's? Do what? You don't start taking half of the 8. You take the 4 out, because what you want is a leading coefficient of a 1 in front of x squared. So this is 4 times, open parentheses, x squared minus 4x. And now then, we got to complete the square inside. So half of the negative, that's a minus 2x. We factored the 4 out. It was a common number. And see, it's this coefficient right here. We got to pull that out so that we can get a 1x squared so that we can complete the square easily. X squared minus 2x, well, we got to take half of negative 2, which is negative 1, and then square it. So that's going to be plus 1. What do we add to the other side? Not a 1. Why is it a 4? Because this 1 that's inside the parentheses is being multiplied by a 4 outside. That's a distribution, right? So on the right-hand side over here, we've got to put a plus 4, right? The 1 that we have here inside on the left is actually being multiplied by this 4 that's on the outside, right? So what we added to the left-hand side was 4. It's 4. All right. Now then, let's go to the y terms. Now the y terms, like we said before, this is a special case. It's already a perfect square trinomial. So for this one, we can go ahead and write it as y plus 3 squared. And so let's take this now. This is 4 times, well, now this is a perfect square trinomial. It's the x minus 1 squared plus y plus 3 squared is equal to 4. And this is almost a circle. The reason why it's not a circle is because we have a coefficient here in front of this square term in x that's different than the square term in y. If those were both the same coefficient, we just divide both sides by that, and that would be it. Question here. Yes. This 6 and the y up here in step 2, right here, right? We don't have to complete the square this time because it's already a perfect square trinomial. If you look at this middle term, 6, right? That's the coefficient of the linear term, the y. What's half of 6? Half of 6 is 3. Square the 3, what do you have? 9. Oh, all right. If it were any number other than 9 right here, I would have moved it to the right-hand side and then completed the square. But in this case, they just gave us a perfect square. So we don't have to go through and do anything with that part. Let me get the question here from Megan. All right, say again.
What happened to 2x?
The 2x right here. The reason for writing this, for completing the square, that method, is so that this, the x squared minus 2x plus 1, can be written as this binomial squared. Every time that you do that method of completing the square, the purpose is to get it as some 2-term polynomial. All right, we take half of negative 2, which is negative 1, and square it. When you add the 1 here, that's inside a set of parentheses that's being multiplied by 4 on the outside. All right? So you didn't add 1 to the side. You added 1 inside that set of parentheses. You added 4 to the left-hand side. So we have to add the 4 over here on the right-hand side. And again, that's the most common mistake. People will put a 1 here on the left and then put a 1 over here on the right, forgetting, oh, there's a distribution there.
No, I thought
Jacob Downey just texted you and said he took pills and slept in, so sorry.
Okay. Well, thanks. That's why we're recording it for Jake today. Okay, question here from Olivia.
and that's not the answer. Is it?
Oh, no, this is not the answer. Okay, we're getting 2 right here. This is the second to last step. My question is, what do you have to do to put this now in standard form for an ellipse? Divide by whatever this number is over here on the right-hand side, which in this case is 4. So I'm dividing by 4. Here, here, and here. In this case, the 4s are going to divide out. That leaves us with a 1 over here on the right. This is going to be x minus 1 squared over, I'm going to go ahead and write that as 1 squared, because I'm going to have to figure out what a and b are here in a minute, plus y plus 3 squared over, instead of writing the 4 again, I'm going to put the 2 squared, because what I'm looking for are the a and b. Not yet. We're just now, the question was, are we done yet? We're just now to where problems 17, 19, and 21 were. We got the standard form. We've got to go through and find all the points. So here we go. What is the center of this ellipse? What's the center? 1 and negative 3. Now, the second question is, which direction is this ellipse opening? Is it vertical or horizontal? It's vertical because this number right here is bigger underneath the y's. All right? So I'm going to move this down just a little bit because it's going to be kind of cramped. And let's add a little space to the page here. Okay. Now that we have the center, I'm finding the foci. And in this case, the foci are going to be vertical. So focus 1 is going to go above. Focus 2 is going to go underneath. But I don't know what that focal length is yet.
A squared minus B squared.
All right. A squared minus B squared. We have 4 minus 1 is equal to C squared, or C squared is equal to what? Well, C squared is equal to 3, so C is root 3. Wow. C is root 3, and I knew what she meant. All right, so what are the foci here? What's focus 1? 1 comma negative 3 plus root 3. And what's the negative 3 is here for the y value, all right? And then we're going up that focal length, root 3, because we're going up. We're going up root 3 units. That's why it's positive. Now, when we come down here, what are we going to have? That's right. Negative 3 is the starting point here for y from the center, right? And now then, what's this one going to be? 1 negative 3 minus root 3. Again, all we're doing is going up root 3 and down root 3 from that center point. That's the plus and the minus root 3.
Okay, when I'm working things out, I don't do that. I just try to 1 comma negative 3 plus or minus root 3. That's about it.
Okay. Now, Abby just said she didn't do that thing I do when I'm writing these out. And the thing that I'm doing, she's talking about, is this visual representation. You don't have to, all right? I do. And I would encourage you to do that, because when you graph this in just a minute, this is going to let you just know kind of what it's got to look like by putting it here. Plus, all of the values here, all the x values are going to be 1 on this major axis. So when I get the next 2 vertices, vertex 1 and vertex 2, they're both going to be 1, 1, and then I got to figure out what that y coordinate is for both of them. Question is from Megan. Ask it again. It isn't always going to be square root of 3, but the ellipses that we're working with, because we have a textbook that they want to use nice numbers. Well, nice numbers, if you look at the eccentricity of this one as well, let's just take a look at the eccentricity since you asked it. Eccentricity is still c over a. It's root 3 over 2. This one is exactly the same ellipse as number 17. It's not not 17, that was 4 over 2, as the same as 19. In fact, the only thing that's different about 19 is 19 was opening, well, it was opening vertically as well. We just got a different center point.
But I meant like on the text, is it possible that it be
Yeah, it's possible that it wouldn't be root 3. They're just using, small numbers so that you're not going a whole lot from it, but it doesn't have to always be root 3. So let's take vertex 1 and vertex 2 here. Vertex 1, well, how far are we going up on the major axis from this center point 1, negative 3? We're going up 2, right? A is 2. So 1, negative 3 plus 2 is negative 1. Well, we've got to go beneath it, and so I'm going to subtract 2. Thank you so much. I'm going to go 2 down from negative 3, which is negative 5. All right? Well, now then we've got to go left and right. We've got to find the 2 vertices on the minor axis. So I'm going to come directly to the left. This is my 3rd vertex. Here's my 4th vertex on the right. What stays the same now? Yeah, the 1 doesn't. The negative 3, because the y coordinate is going to be the same. All right? So this is the same here and here. But how far are we moving? We're moving the b, which is 1. That's the distance on the minor axis. That's right. So 1 to the left of 1 is going to be 0. 1 to the right of 1 is going to be 2. And once you have these, look how many points that is. That's 7. They're going to ask for all of them, right? When you're graphing, if you were to try to, they're going to ask for the vertices, typically, and the foci and the center. They're not going to ask for any other points because the other points are not going to be nice points, all right? We're just going up, down, left, right from the center, and then find where the foci are. All right? Any other questions quickly before I pause the video for Jacob? Because what we didn't get to were problems 31 through 41, where it's got words. Something like, I don't know.
I have a question.
Go ahead. Olivia's got a question. She's wanting to finish this up, and I was going to say, yes, we can, but I'm going to give the evens as well. It should be easier. Oh, we got the ACT at Southeast? All right.
Are you going?
Northwest, huh? Yeah, I always take it. See how good I do.
Do you really?
Well, that's pretty something
Yeah.
to do.
I know.
Yeah. All right, we'll finish up these odds then for Monday. But what I want you to concentrate on are 31 through 41. These are going to be the ones that don't just give you the equation. These give you problems that are, you got to figure out the lengths A, B, and possibly C from what's listed there. Now the last 2 that were listed, I think it was 49 and 50, also some good word problems. Okay, so don't forget about those 2. And we'll let that be it.